Welcome everybody to the last video on quadratic equation. In this video, we are going to be addressing quadratic equations with fraction and quadratic equation with square roots. Now, I advise you to be having a pen and a paper in front of you so that if some of the things that I'm writing here are not visible, you can write them because I'll be saying every single thing that I'm writing. Okay, so for equations with fractions, what is important for you to note is, and remember, is that you cannot divide by 0. If you divide by 0, whatever you divide by 0 is undefined. So before you even go anywhere, you know that if you have x minus 1 as a denominator here, if x is equals to 1, you'll have 1 minus 1 is equals to 0. Therefore, you cannot have xs equals to 1. So your first answer, your first free answer is x is not equals to 1. We write it like that. And then the same thing applies here, x plus 7. If you have xs minus 7, then you know that your expression is undefined. So you cannot divide by 0, at least for this level of mathematics. So then your second answer is going to be x is not equals to minus 7, because minus 7 plus 7 is 0. Your examiner might just give you marks for that. Thought I mentioned that. So I'm gonna write it on the left that x is not equals to 1 and x is not equals to -7. So that is the first important thing for you to consider when you are dealing with fractions. Okay, all right. Now that you got that, let's get to it. Okay. So now, to get rid of fractions, you first need to get rid of fractions so that you can have a workable structure. So if you multiply this side by x minus 1, it will cancel this. But what you do on the left, you must also do on the right. Okay. And then if you multiply this expression by x plus 7, it will remove the denominator. But then what you do this side, you must do that side. Alright? So you can just go ahead and multiply by both. So you can multiply both the left and the right by the same items, because if you have 2x, I'm just going to give you an example. If you have 2x, let me click the other one. If you have 2x, if you have 2x, right, is equals to c. Okay, right? Or let me just say, if you have 2 is equals to 1 plus 1. If you multiply this by 3 and you multiply this by 3, this expression is still going to hold, because 3 times 2 is 6, and then 1 plus 1 is 2, 2 times 3 is 6. You see, no matter what you use, if you use the same on the left and on the right, it's going to it's not going to disturb the equation. It will remain as such. Okay, so without further waste of time, let's get to it. So we are going to multiply the left hand side with the same thing that we multiplied the right hand side with. So we're going to say, we're going to take x minus 1 into x plus 7, and then we're going to multiply x minus 2 over x minus 1 with, all right, and we are going to multiply the right hand side with the same thing, x minus 1 into x plus 7. We're going to multiply this to 2x minus 1 over x plus 7. All right, that is how we're going to get rid of this. So this will cancel that. Then we'll be remaining with x plus 7 into x minus 2 is equals to, on this side, x plus 7 is going to cancel x plus 7 because this is a fraction as well. All right, so then we'll be remaining with x minus 1 into 2x minus 1, like that. So we got rid of fractions now. Okay, I hope that is clearly visible. We got rid of fractions. Okay, and then now we're going to be multiplying this. So x times that will have x squared, x times that will have minus 2x. This times that is going to be 7x, and then 7 times minus 2 is going to be negative 14, which is equals to x times 2x is 2x squared, x times minus 1 is minus x, minus 1 times that is minus 2x, minus 1 times minus 1 is positive 1. Okay, and then we are going to be grouping the like terms. All right, so we have x squared, and then the other x squared is on the other side of the equal sign. We take it to this side, is going to be negative 2x squared. All right, okay, and then we take in the x's. We have a minus 2x this side, minus 2x. We have a positive 7x, all right, and then we have a minus x that side. Coming this side is going to be positive x, and then we have another minus 2x. Coming this side is going to be a positive 2x. Okay, we remained with the constants. All right, these are like terms, these are like terms. Now, coming to the constant, we have a minus 14 this side, and then on that side we have a positive 1. Is going to come this side, is going to be a minus 1, and then we'll be left with a 0. Okay, now x squared minus 2x squared, we're going to be left with minus x squared. Now we have 2x, which cancels 2x, okay, which minus 2x, which cancels positive 2x. Then we have positive 7x plus x. Then we're going to be having a positive 8x. Okay, like that. All right. And then minus 14 minus 1, we have a minus 15, which is equals to 0. Our equation is now in standard form. We can factorize it, or we can use the quadratic equation, but I'm not gonna go into it because I've dwelt a lot on how to factorize. I've shown 3 types of ways that you can factorize. So here you will just divide by minus 1, minus 1, minus 1, minus 1, and then you will get x squared minus 8x plus 15 is equals to 0. So the factors of x squared will be x and x. The factors of 15 will be 1 times 15, right, will be 3 times 5. 3 times 5 gives us 8. So let's just go ahead and get to it. 3 times 5 gives us 8. 5, 6, 7, 8. So we'll just go ahead and factorize it. So we're gonna be having 3 and 5. Okay, and this will be negative, and this will be x. This will be x. So you're gonna have minus 5x and minus 3x is going to give you 8. Okay, so and then so x is equals to so here you will have x minus 5 is equals to 0, or x minus 3 is equals to 0. So your x will be a positive 5, or it will be a positive 3. And then you know when you get to this stage, you go back and you substitute into your equation to see that which one is true, if not both, and which one is correct and not. Okay, so that is how you deal with your fractions. So the key is how to get this. So you just take this your denominators, you multiply both expression on the left and on the right with. Okay, I'm just gonna go ahead and remove the last bit so that I can have a clear distinction for my second problem. Okay, so for my second problem, we now having square roots. Now, like I have explained in the previous problem, that when with fractions you just look out for the denominator. So with square roots you look for the terms inside your square root, that they must not be negative, because if they're negative, they are like you have x plus 2. If x plus 2 is less or equal to, okay, if it's less than 0, if it's less than 0, therefore your roots are not real. So therefore x cannot be less than a negative 2. Okay, so x cannot be less than a negative 2, because if x is less than a negative 2, therefore you have a negative under your square root. So your examiner might just give you a mark for that, depending on how and who is she or he. Okay, how considerate or clued up. Okay, let's not get too far. Right, so that is important. So that is what you need to look out for when you have square roots in quadratic equation. All right, so now the first thing that one would want to do here is to have this term isolated, the term with the square root isolated. Now to do that, you will then take the x that side, or you can take this term itself that side and remove that 2, bring back that 2, or however you want to do it. Most people understand better when the x terms are on the left, but we will bring it back. So we'll take this x to the other side. So you will have 3 the square root of 3 times the square root of x plus 2 is equals to 2 minus x. We've taken the x across. Alright, so that we can be able to remove the square root. So now we can remove the square root. To remove the square root, we square everything. One could also, before putting the square root, divide everything by 3 so that the 3 goes to that side, or you can do it this way, it's still fine. So what you do on the left, you do on the right. So 3 squared will be 9 times this, and then the square will remove the square, so that will be into x plus 2. Okay, is equals to 2 minus x into 2 minus x, like that. Okay, so now you will have this side 2 times 2, 4, 2 times negative x, negative 2x, 2 times negative x times 2, negative 2x, negative x times negative is positive x squared. Okay, so this side will have 4 minus 4x plus x squared. This side will still have 9x plus 18. So now we're going to take our x squared back to the side. We're going to have negative x squared. We're going to take our 4x, negative 4x this side. We're going to be having positive 4x. We will be taking this 4, this side will be having negative 4, and then this side will have plus 9x plus 18 is equals to 0. Now we're going to be adding the right term, so we'll be having negative x squared, this and this, 4 and 9x, 4x and 9x. So that will give us plus 13x, and then we have minus 4 plus 18 will be left with positive 14 is equals to 0. We can divide everything by a negative so that we remove this negative here. So then we'll be having x squared minus 13x minus 14 is equals to 0. You can go ahead and factorize this and get your values of x, or you can plug it into a quadratic equation. All right, so I can already tell that because of 13 and 14, the factors of 14 that will suit us better will be 1 times 14, so that 14 minus 1 gives us 13. So we can just go ahead and continue with it. We'll have x this side, we'll have 14, we'll have 1, right? And then we'll have a positive 1, we'll have a negative 14, because minus 14x plus 1 will give you minus 13x, and then positive times negative will give us a 4. So your x will be x plus 1 is equals to 0, or x minus 14 is equals to 0. Therefore x will be negative 1, or x will be a positive 14. And then you plug this into the equation like I explained the previous time. So let's do that and see. So if we take 1, if we take negative 1 and plug it here, so you on this expression, let me do this. You're gonna be having negative 1 plus 3 into the square root of negative 1 plus 2 is equals to 2. So this side will be having minus 1 plus 1 is positive 1. Square root of 1 is 1. 1 times 3 is 3. So having minus 1 plus 3 is equals to 2. So minus 1 plus 3, it is 2 is equals to 2. So so meaning x is equals to minus 1 is correct. Let's see x is equals to positive 14. So if we have this again, x plus 3 square root of x plus 2 is equals to 2. Let's see. So we'll have a positive 14 in place holding for x. 3 square root of 14 plus 2 is equals to 2. So 14 plus 2 is 16. Okay, so the square root of 16, okay, 14 plus 3 square root of 16 is equals to 2. Okay, I can already tell that this is not going to hold because 14 is already greater than 2. Okay, so what is 16? 4 squared. 4 squared is 16. So the square root of 16 is 4. So 14 plus 3 into 4 is equals to 2. 3 times 4 is 12. So 14 plus 12 is not equals to 2. Because this is 26, which is not equals to 2. So therefore you're going to say x minus 4 is not a root of the expression back. So you're going to get a mark for that. That is definite for sure. You're going to get a mark for that. Okay, you're going to get a mark for that. So that's how, in short, that's how you deal with completion of a square. And when you have fractions, and then when you have square roots. Okay, so when you have fractions, you multiply by the denominator, and then when you have square roots, you multiply, you look for that your square root does not become negative. So now this topic of square roots being positive is linking to what we call the nature of the roots. The nature of the roots in quadratic equation. Okay, so in summary, to solve a quadratic equation, eliminate fractions, multiply by the lowest common denominator, remove the square root, and look that there is no negative value of the square root in both. Write the equation in standard form, try to factorize, or use the formula. Complete the square only if specifically told to do so. Otherwise, just use the quadratic formula. And then the discriminant, the discriminant or the delta should not be negative, and then the roots are actually the x values. Okay, so that is in summary. But then now there is one expression that we're going to be doing that is going to talk to us about the discriminant. So in the quadratic formula, x is equals to minus b plus minus the square root of b squared minus 4ac all over 2a. Now, this expression here under the square root, which is b squared minus 4ac, we call it the delta or the discriminant. Delta or the discriminant. It determines the nature of our roots, the nature of our x values. The roots are x values, the value of x when we solve for x. So it determines that. So depending on this, as you've seen in the previous videos, our roots can either be real or non-real. They can be a perfect square, and so on and so forth. And then in this example, they've given us 2x into x minus 2 is equals to k, right? And then they say solve for k if, solve for x if, right? Solve for x if, all right, solve x if x is equals, if k is equals to 0, right? If k is equals to minus 2, if k is equals to x minus 9. All right, so we're going to be doing that so that we can see what happens to our expression when we do that. So now if k is equals to 0, if I can take it this side, if k is equals to 0, you're gonna be having 2 into x minus 2 is equals to 0, and then you will just multiply, and then you'll have 2x squared minus 4x is equals to 0, and then you'll divide everything by 2, then you'll have x squared minus 2x is equals to 0, and then you'll factorize, you'll have x into x minus 2 is equals to 0, then you have x is equals to 0 or x minus 2 is equals to 0. Okay, then here you have x is equals to positive 2. So you have your root as x is equals to 0 or x is equals to positive 2. All right. Okay. So in this case, those are your roots. And then in another case where k is minus 2, okay, where k is minus 2, you have 2x into x minus 2 is equals to minus 2, right? And then you will likewise the same, multiply this, you'll end up with 2x squared minus 4x is equals to negative 2, and then you bring the 2 this side, you'll have 2x squared minus 4x plus 2 is equals to 0. You divide everything by 2, you'll have x squared minus 2x plus 1 is equals to 0. You factorize this equals to 0. You'll have x, you'll have 1, negative, 1, negative, because you have a negative 2 there. So you'll have x minus 1 is equals to 0 because they are the same basically. So then you'll have x is equals to 1, okay, as the nature of the roots there, okay. Then let's try the last scenario. When k is x minus 9, so you'll have 2x into x minus 2 is equals to x minus 9, place holding for k. So likewise, you'll have 2x squared minus 4x is equals to x minus 9. All right, then you'll have 2x squared minus 4x. You'll bring x this side, it will be minus x, will bring minus 9 this side, will be positive 9 is equals to 0. And then you'll group the like terms and add them. So you'll have 2x squared, these are likes, so you'll have minus 5x plus 9 is equals to 0. Now, the factors of 9 is 1 times 9 or 3 times 3. So we'll most likely win with 3 times 3. We can try that. Let's see. So we'll have 2x, and then we'll have 3, and then we'll have x this side, and then we'll have 3 is equals to 0. So let's look for which sign will be suitable. So the sign that will be suitable, we must have a plus and a minus. Actually, if we have a plus and a minus, we're gonna end up with a minus there, so we can't have that. So if we have a minus and a minus, we're gonna not come up with that very well, because we're gonna have 2 times 3, which is 6, and then 6 and that, so we're not gonna have that 10. Okay, so if we take 9 and 1, if we take 9 and 1, so if we have 1 this side and we have 9, right, still we're not gonna win, because 9 minus 2 is 7. So if you come across an expression like this, you go on, you plug in your quadratic formula. Okay, you use your quadratic formula. So you'll have your A equals 2, your B equals -5, and then your C equals +9. Okay, your C equals +9. So if you plug this into your quadratic formula, but let's just put it here a bit before we even put it there. So you have your B squared, which is -5 squared, and then you have your 4A, which is 2, and then your C, which is 9. Okay, so you have 25 minus 4 times 2 is 8. Or let's start by saying 2 times 9 is 18. 18 times 4, so 18, 18, 18, 18. So you have 8 plus 8, which gives you 16. And then 16 times 2, that will give you 32. So you have a 2 here, you carry 3. 1, 2, 3, 4, 5, 6, 7. So you have 72. So that will be 72. 25 minus, already this is a negative. So you're gonna have a negative number under your square root. So the roots of these are going to be not real. Okay, because you have a negative under your square root. So your discriminant is negative. So the roots are not real. Here, the roots are real because they are equals to 0 and they are a positive number, and it's perfect square. This one is not a perfect square, sorry. So this is a perfect square. This is not a perfect square because the square root of 2 is not a perfect square. So, but then this is a real number. 2 is a real number, so your roots are actually real. And 0 is also, I'm not sure if it is real or natural. I'll find out and get back to you guys on that one. And here you also have a real number. So let's hear what they say in place of this. So in the case where x is equals to 1, this has one solution because these are the same. Okay, and then the first one, if your roots are equal to 0, then we say the roots are equal. Okay, the roots are equal. And then if the roots, if the discriminant is negative, then we say the roots are non-real. Like in this case where we have a negative under the square root. And then in the case where no real roots, that is where you have a negative under your square root. You don't have real roots. Okay, so let's wrap it up like that. I hope some of you took something home, and yes, so we ending this video there. So just remember, when your roots are equals to 0, then they are equal. When your discriminant is less than 0, then they are not real. When your discriminant is greater than 0, then you have real roots. Okay, you have real roots. We will revisit this part in more details because you can have it in more details. I will just bring a table for you guys. So in a bit, you must remember that in the quadratic formula, you have a b squared minus 4ac, which is called delta, or it's represented by that. It is also called the discriminant, and it determines the nature of your roots. And then if they ask you for the nature of the roots, this is what they're actually asking you. So you don't even have to go and plug the whole thing and find the value of x. You can just take b squared minus 4ac to save time, which is this, and then plug it in there and see what number you get. If the number you get is less than 0, like in our case here, then you know the roots are not real. If it's greater than 0, you know that the roots are real. If it's equal to 0, you know that the roots are equal. Okay, so there is a part of rational and non-rational roots. That's the part that I wanted to get to. So if you have the square root of 25, then as the value of x, then your answer is going to be 5. Okay, this is a rational. All right, so your roots are rational. If under there you have a natural number like that, the roots are rational. But then if you have the square, your x is equals to the square root of 5, which we know is gonna give you some decimals, blah blah blah, going forward, some number, comma, something. So we say the roots are irrational. Okay, so if this is a perfect square, you get a whole number, then the roots are rational. If it is not a perfect square, the square root of 5 is gonna give you something. I don't have a calculator with me, but it's not a perfect square. So if it's not a perfect square, then the roots are irrational. Okay, I think that sums it up. There's actually nothing more to this chapter. That is it. Okay, thank you guys for watching today's video. This marks the end of quadratic equation. If you have any questions, you can write them in the description, and I will be more than happy to attend to them. And don't forget to like and subscribe. See you in the next chapter.